Hello, in this video, I'm going to show you how I use Azure Machine Learning Studio to develop a predictive model for credit risk based on datasets of past applicants, financial information, credit history, etc. So basically, it's just trying to classify the high risk applicants from low risk group. Okay, so in this page, so this is sort of machine learning studio, right, on Azure. So I got a free account. So in this page it contains predictive experiments and training experiments. Let's start it from the training experiment, which is demo number 2. So first of all, let me give you a free view, full view of this predictive models. So it contains many modules. I will walk you through module by module. Right? So start from the first module. So this module just ingest data. So the original data got a 1,000 row and 21 columns. So each row, of course, represents each applicant, and the first 20 column represents predictor variables, like credit risk, or credit history, employment status, personal information, etc. So the last column here just uh, just contains the risk information, high risk or low risk. Right? So the second column just give each column name more meaningful. So you can see here the column name changed. Right? Um, before training using machine learning to train the model, usually we will split the data, original data. In this study, just 50, half and half. So half of the original data goes through training, like here, from the left hand side port, and half of the original data goes to testing data, so to test the model, right? So I also here just put some R script. So the reason is that because in the original data set, the records belongs to high risk applicants is much lower than the records number of the lower risk applicants. So this um, R script putting here is just trying to duplicate the number of the high risk applicants records, right? Just make it balanced so that the imbalanced data set will not influence models predictive performance. Okay, so let's jump into actually here I just using two kinds of machine learning algorithms. One is um, one is here is boosted decision tree, and the other here in this part is support vector machine. So let's start it from the boosted decision tree first. So basically, using this algorithm, boosted decision tree, we first train the model with the training data feeding from here, and I will just score the model. So let's see what happened. So the model has already been trained here within the scoring model. So you can see that. So this is original data. original response variable, so target variable, high risk or not. So here is this column scored labels means predicted predicted results, right? The predicted results also being represented by the second column named scored probability. So here's the probability is from 0 to 1. Okay, this is how model being scored, right? That the one thing I just want to mention is that the scored model just not using the training data, but using a testing data, right? 50% of original data goes from here to here, right? So the model has been tested, right? So the same thing happened here is for support vector machine. So this modules represents the support vector machine. So the same thing happened here is that um, just same thing happened here is that support vector machine also give out the give give out the scored labels and scored probabilities, right? Okay, so the next step we want to do is just to compare which model is better, which algorithm is better. So each output from each algorithm just became a input um, for this evaluate model. So this module just trying to let's visualize it, just trying to compare the predicted performance of the two predictive algorithms. So the blue one represents the boost decision tree, and the red one represents the performance of the support vector machine. Obviously, this is a ROC curve, and so normally we will compare the model performance using one single metric named AUC, right? So the AUC for the boosted decision tree, it's like this number, but for the support vector machine, we represented by the red curve, is just lower than the boosted decision tree, right? So, well, there are other scores like confusion matrix, accuracy, and precision, but here we only focus on the AUC, right? Okay, so we will use boosted decision tree as our final model to just published and deployed online on the Azure Web Service. So here, let's go back to the experiments. So here I have already just removed in this. I have already removed support vector machine. Original is here. I removed and return only boosted decision tree for the final model. And the final model has been pushed in onto the Azure web service. So it's like here, right? So after all these steps, we can deploy this final model as web service. Because I have already done that, so I have to overriding this original one. So now predictive model not only used by me, but also by anyone being authorized online. So either I just can show you if anyone access to this machine learning web service has been authorized. So after loading the data, anyone can use this predictive model to assess the credit risk, right? So if I click the test, and here just like a 21 columns here, if I just get some give this text box as inputs and click this button, the results, the final results, high risk or low risk will show here. And it also works in the sort of batch mode, right? So anyone can now using the machine learning website